It's time for our WeatherWhys segment where we take something complicated in the world of meteorology and make it simple for you to understand. Let's talk about lake effect. I think most understand the concept of lake effect snow. That is when you take cold air and you bring it over warm water, what do you end up getting? Lake effect. Here's how it works. You have the warm lake waters. Here comes the colder air aloft. When you get that colder air aloft over the warm waters, you create instability. Warm at the surface, colder air aloft, you get upward motion. The water from the lakes, that's moisture getting northward, you up into the atmosphere, you form clouds, you form precipitation in time, and then you start getting the lake effect snow, and that moves inland. So that's kind of the easy explanation. I want to break it down a little bit for you more. Let's talk about the mechanics of it. Okay, let's talk about the warm water and the cold air aloft. You need at least a 23-degree Fahrenheit difference between the lake water and the colder air aloft. That's at around 5,000 feet. You need cyclonic winds at the surface. I'll explain. Wind direction and the fetch of that water determines the location and the strength of the snow. What in the world am I talking about cyclonic curvature? Well, if you think about it, a lot of the cold air always occurs on the backside of storms. So you have large-scale descent. But you see how these winds are moving counterclockwise here? This is called cyclonic curvature. This, or cyclonic curvature, this you get some low areas or small-scale ascent. Then the cold air over the warm waters, water temperatures in the 40s. We're looking at temperatures at 5,000 feet, by the way, in the teens. And then you get the lake effect, and the west-northwest flow comes on in.